law of chemical equilibrium and the equilibrium constant. In a reversible system, like we have A plus B, and it forms the products C and D. This is, let's say, reversible reaction, and let's say the coefficients over here are A, B, and C and D. These are the stoichiometric coefficients in a balanced chemical equation. That's what you write. So if you have a reversible system, and we know that once you attain the state of equilibrium, both rates are same. Rate of forward reaction equals to the rate of backward reaction. The rate of a forward reaction here, you can say the rate at which the reactants A and B and they combine and form the products. The rate of, you can say, rate of forward reaction will be equals to, that depends, actually you can say it depends on the concentration of A and the concentration of B, and power coefficients equal to power equal to their coefficients, A and the B here. This is as per the law of mass action. Okay, so you can also say that rate of a forward reaction will be equal to constant K into concentration of. So the rate of forward reaction as per the law of mass action will be equal to the rate constant K for the forward reaction times concentration of A, power equal to the coefficient there, and B, power equal to the coefficient in the balanced equation. So you can say the rate of backward reaction, that depends on the concentration of the C and D, right? Depends on the concentration of the C and D. Each term raised to the power equal to their coefficients, C and D here. Okay, C and D here. C and D here is the coefficient of the C and D, and you can say it is equal to rate constant K for the backward reaction. This is the constant, right? Rate constant, actually, which will be rate constant K, C power coefficient, D power D, like that. And once you attain the state of equilibrium, that means the rate of a forward reaction will be equal to the rate of backward reaction. So forward reaction is equal to the backward reaction. So when both rates are same, so I can say that these two quantities are equal, correct? So I can say here the rate constant K for the forward reaction, A power A times B power B, right? The coefficients there will be equal to the rate constant KB C times D. Okay, or I can rearrange it also, when the two things are here constant. So I can rearrange it like this. I can say the rate constant Kf for the forward reaction by Kb for the backward reaction will be equal to the concentration of the this Kb, I take it to this side, and the concentrations to this side. Keep the concentrations to one side and the rate constant from the other side. So what you will get, concentration of C power C, concentration of D power D. Okay, that will be divided by the concentration of the A power A times concentration of the B power B. So that will be the same, right? The ratio of the rate constants will be equal to the ratio of their concentrations, actually. So that will remain the constant. See here, these are the two this is the ratio of the two constants here, right? Isn't it? Kf by Kb. So this is what you call as a equilibrium constant here, correct? This is what we call as an equilibrium constant. So what is equilibrium constant now? Equilibrium constant, you can explain that equilibrium constant is the ratio of the rate constant for the forward reaction by the rate constant for the backward reaction. Or you can say this equilibrium constant is the ratio of the concentration of the products and the reactants over here. Let's take here an example. If this is our reversible reaction here, okay, and how do we write down the this equilibrium constant for this one? So we can say equilibrium constant for this reaction will be equal to, you can see it is the rate constant Kf for the forward reaction and the Kb by the backward reaction. So it is Kf for the forward reaction by Kb for the backward reaction. You can also explain it in terms of the concentrations, right? So that will be equal to the concentration of products by the reactants, and each term equal to the raised to the power equal to their coefficients there. So that means it will be the concentration of the products, which is ammonia here, NH3, concentration of the ammonia power 2, because the coefficient there is 2, or by what? By hydrogen concentration power 3, and nitrogen concentration power 1. So this will be the equilibrium constant for this particular reaction over here. And let's take one more example here. For example, we have a hydrogen here, and that reacts with the chlorine, or let's say the iodine. So how do we write down here the equilibrium constant for this particular reaction? For this reaction, you can say the equilibrium constant will be equal to the concentration of the product HI here, right? Okay, power 2 upon concentration of hydrogen times concentration of iodine over here. And what if you for example, reverse this reaction? If I write down the same reaction like this, if I start the reaction with the HI, okay, I'll reverse it. HI under equilibrium with the H2 and I2. So what will be the equilibrium for this reaction? The equilibrium constant for this reaction will be equal to concentration of products over here, that is hydrogen, iodine by HI power 2, right? This will be the equilibrium constant for this reversal reaction. So if you reverse the reaction, this equilibrium constant will be different, correct? And let's suppose, just for an example, for the sake of understanding, for example, if you look at here, right, suppose if the ratio comes out to be, let's say it is 4, right? Suppose the ratio is 4 here. So therefore, what do you think, what will be the equilibrium constant for this reaction? Just for an understanding purpose. If this, ratio here is 4, so what will be the, for this, reaction? It will be 1 by 4, right? Isn't it? It will be 1 over 4. So whatever, if you have a particular reaction, and if you reverse it there, the new equilibrium constant will be 1 over the previous equilibrium constant. Correct? Let's take another example here. This is a reversible reaction, and here we have an equilibrium between nitrogen, hydrogen, and forms ammonia, and these are the equilibrium concentrations. And if you know the equilibrium concentrations, the concentration of the different components once you attain equilibrium, so you can find here the equilibrium constant over here, right? So let's suppose this reaction here, I'm going to write down the equilibrium constant first of all for this particular reaction. That will be the concentration of the ammonia over here, power 2 here, upon concentration of nitrogen and hydrogen over here. So hydrogen will be power 3, right? So let's put the values over here. We know the molar concentrations, in the equilibrium state here. The ammonia here, it is, what's that? It is 1.2. It is 1.2 times 10 to the power negative 2, right? This is the concentration of the ammonia, power 2, right? Over here, the coefficient here is 2. So divided by the concentration of nitrogen, which is 1.5 times 10 to the power negative 2. This is the concentration of the nitrogen, and the concentration of hydrogen will be 3.0 times 10 to the power negative 2. So power here it will be 3, right? Because the coefficient over here is 3. Okay. So once you solve this, these values over here, 1.2 and this one, right? So what you find? We find that the this equilibrium constant for this reaction is 3.55 times the 10 to the power negative 2. So hope you got it. Thanks for watching the video. Bye for now.